Hi students, welcome to my living room. How are you doing today? I hope you are all safe and healthy, and thanks for joining me today. It is just me. Right now Kitty's sleeping, Doug is sleeping, Bill is at his place, and I thought I'd give this a try on my own. Today we're going to be looking at 3.4a and b. I'll be posting two videos. I just like breaking it into two pieces. We are going to be solving exponential equations using the property of logarithms, the power property. So the first thing we're going to do is you may want to just pause the video and just write the notes before we get started, right? So isn't that nice? You can pause me. Excellent. And so here are our steps. I try to keep them as short as possible so that this video doesn't take too long for you. So the first thing we're going to do is isolate the base. That means that there's no other operations such as multiplication, division, addition, or subtraction. That will happen in example 4. The next thing we're going to do is take the natural log of both sides of the equation. You don't have to choose, right? There's lots of different bases, e, 1/4, 64, 5. But if we just simply take the natural log of both sides of the equation, it will solve the problem for us. Remember that natural log button is on the left-hand side of your calculator. We're going to apply the power rule of logarithms to help us solve, and then we will solve for the variable and check. We may not be checking today because we will be totally right every time, and it'll keep the video shorter. So example number 1. We could actually solve this by hand if we wanted to, but we're going to use our calculator to do that. We have a base of 1/4 and 64. They are both alone, they are isolated, so we're going to take the natural log of both sides. So here we go, natural log of both sides. This allows us to bring the exponent that we're trying to solve for out front and multiply it by the rest of the expression. So we have x times the natural log of 1/4 equals the natural log of 64. Notice you could get both of these values from your calculator right now, but I prefer to get all my math to one side and then do it. So I'm going to divide both sides by the natural log of 1/4. We're going to pop this into the calculator using parentheses and D so that the calculator does what we want. So the natural log of 64 divided by the natural log of 1/4 is a really nice -3. If you had done the natural log of 64 separately from the natural log of 1/4, you would have had crazy decimals, which is fine, but it's kind of nice that when you do the math at one time, you get one nice answer. Let's move on to number 2. E to the x equals 4. Again, base of e, base of 4, both are isolated. We are going to take the natural log of both sides. We are going to bring the exponent out front and multiply it by the rest of the expression. This is why using the natural log is so nice. If you remember, the natural log of e is 1. There we go. And so our only job is to type in the natural log of 4 into our calculator and round it to the 3rd place. There we go. Next, example 3. Looks a little bit more complicated. We're still going to follow our rules. We have a base of e on both sides. They are isolated. We are going to take the natural log of both sides. This allows us to bring both exponents out front and multiply it by the rest of the expression. And right now, I could show that 2x is being multiplied by the natural log of e, but we know that's 1. We don't need that. So we're just going to put an equal sign here. We will bring x squared minus 8 out front and multiply it by the natural log of e, but we know that's 1. So we don't need that. There we go. Now, this looks quadratic, of course, right? They're going to do this to you. We will subtract a 2x from both sides and set the expression equal to 0. There we go. Now we are looking for two numbers that multiply to a negative 8 and add to a negative 2. You would tell me that is x minus 4 and x plus 2. And then you would tell me your possible solutions would be x equals 4 and x equals negative 2. There we go. Now when we go back to the original equation that we had here, we would find that both of those answers are true and work well in the equation. All right, example 4. Example 4, notice there's a base of 5 and 32, and the base of 5 is being multiplied by the 2. This is the case where we have to isolate the base. We're simply going to divide both sides by 2. Here we go. We have 5 to the x equals 32. Let's take the natural log of both sides. Let's bring our x out front and multiply it by the natural log of 5. And that equals the natural log of 32. Again, you're welcome to get both of these from your calculator, but let's put everything on one side and do the math at one time. Let's divide by the natural log of 5. There we go. And our x equals, let's pop this into the calculator here. That would be the natural log of 32 divided by the natural log of 5. And to the third place, 2.153. Last problem. It's a story problem, of course. Suppose you put $2,500 into an account with a rate of 4.5%. That will be 0.045, of course. How long to double your money? We are going to use A equals P to the E raised to the RT. And if you remember, P is your initial amount, R is your rate, T is time. And A is your output amount after time has gone by, right? And so notice that they gave us that $2,500 is deposited. That's going to be our P. They gave us the rate is 0.045. They are asking us for time. And they are asking us for the time when the money will double. So to double 2,500, of course, that would be 5,000. There we go. We're trying to solve for T. This looks a little bit more complicated, but you know we need to isolate the base, right? So we're going to divide both sides by 2,500. And of course we're going to get a 2 on the left because we doubled our money. There we go. The next thing we're going to do is take the natural log of both sides. Which allows us to bring our exponent out front and multiply it. I think I'm going to have to get lower on the board here. So we have the natural log of 2 equals 0.045t times the natural log of e, which is 1, so we don't need to show that. Okay, we're almost there. We just need to divide both sides by 0.045. So it turns out anytime you want to double your money, it's always the natural log of 2 divided by the rate. If you had wanted to triple your money, it would be the natural log of 3 divided by the rate, and it will tell you the time. Let's pop that in. That's the natural log of 2. I'm going to hit enter, get that first. Divide that by 0.045. There we go, and that's 15.4 years. There we go. So we have finished our lesson for half the lesson for today. And let me just grab the camera since this is our first time together. And let's see if we can go find the cat. Let's go take a look. All right, here's it. Let's take a walk through. I need to vacuum. There we go. Here's the kitchen. Right? Here's my little setup here. Let's see if we can find the cat. Oh, there she is. This is a lot of cat, people. This is Princess. Hi, Princess. All right, class. I'm going to end now and post another video, and we'll see what Kitty's doing after that one.